Okay, can you hear me? Can you hear me? And can you hear me, Pizza, as well? Can you hear me speak? Brilliant. And can you see the screen share? Brilliant, brilliant. Right, we'll give everyone a couple of minutes. Hoping you've got the questions. Hoping you can see the screen share. That's great. So we're all up and running. Right, sorry for the delay. We're just going to wait a couple of minutes, give everybody else a chance to get here. So, Pizza, given that you've already done your GCSE, I might need your help with some of these. I'm not really, but they are the hardest questions that I could find on each of the topics that we're doing. Okay, so good luck to everyone. Right, we've only got 3 people so far, so we'll give it a couple of minutes. Yeah, I agree on the vectors, but I couldn't include every topic. So what I did was I wrote a list of 11 topics, and then I just found the hardest question on each topic I could. Oh, thanks, Pizza. I bet it was because I moved from one screen to the other or something like that. I just was trying to be too clever, I think. Okay, we've got 5 of us, so we'll give it a couple of minutes, and then we'll get started. Thanks for your patience, everyone. Okay, then there were 7, so we're getting there. So just hit like if you would, because then I think that other people who are hanging around on YouTube might get a notification that we're in here. So if those of you who are here could hit like or something similar. Obviously, this is not going to be the most crowded YouTube live ever, but that's no problem. Okay. Incidentally, Bean, on the vector questions, there's a film on my channel of every vector question that's ever been asked, and a lot of them are ratio questions, and you just get into the swing of it, as I'm sure you've realized. You just kind of follow a routine. Right. Okay, I think we ought to crack on. So I'm hoping you can still hear me, and I am going to make a start. Right, now I can't see your chat while I'm working on the maths, so I can't see your chat anymore, but I'm going to start with this question here. Right, I'm just going to get rid of my advert for Past Paper Club, but if you are taking your IGCSE soon and you want to know about my Past Paper Club, then send me an email and I'll tell you all about it. Right, okay, so hoping we're ready. Right, here we go. Right, in this question then, we've got a line with this equation, which I'm underlining in green, and a line with this equation, which I'm underlining in red. And you know the 2 lines intersect at 2 points, A and B. So you just have to find the coordinates of A and the coordinates of B algebraically. So what this is asking you to do is it's asking you to solve these 2 equations simultaneously to find the points that lie on both lines. So at the risk of doing it for you, and you just watching me, I'm going to pause now and give you a chance to have a think about how you would solve those 2 equations simultaneously, what you'd actually do to do that. Okay. Now, if it were me, I would probably take that top equation and find an expression for x, and then I'd substitute that into the second equation, and I'd be careful not to mess up my algebra. All right. So the top equation gives me this expression for x. With any luck, by the way, you're working ahead of me, really. I get 2y minus 1. That's what x equals. And now I'm going to substitute that expression for x into the second equation. And the trick is simply not to mess up your algebra. So take it very steady and try and resist that year 11 tendency to miss out stages of working. Look at this. When I'm doing x squared, I'm even writing 2y minus 1 times 2y minus 1 minus, and then put that 2y minus 1 in a bracket. And now you can work at simplifying that equation. So I'm going to have 3y squared, 7y plus 16. I'm multiplying out, I'm expanding these two brackets now. So I'm going to have 4y squared minus 2y plus 1, minus times a minus. And now I've got a minus outside the bracket here, so I'm going to need to be careful again. They throw every little algebraic issue at you when you're working on these questions. And now you can simply write that down again, simplifying the left-hand side. Okay, that gives me 3y squared plus 7y plus 16. Simplify this carefully. The trouble is, whenever I say don't mess it up, I then tend to make a mistake. Okay, so I've got minus 6y here, and then plus 2. And now this is looking like a more straightforward quadratic equation. So I'm going to set it equal to 0, and then factorize. So I'm hoping that you're all now setting that equal to 0, and then you can look to factorize. Now, if I was setting this equal to 0, I think I'd move everything onto the right-hand side, because that will give me a positive x squared, which is much easier, let's face it. So from both sides, I'm going to subtract 3y squared, I'm going to subtract 7y, and I'm going to subtract 16. So that's going to leave me with 0 there. Y squared minus 13y minus 14. So what this boils down to, first of all, is solving this quadratic equation. Have a go at doing that by factorizing. Although, of course, you could use the formula if you really wanted to. Okay. Nobody's shouting at me in the comments, so I assume everything's working okay. Right, factorizing that. Now, they multiply to a negative, to that negative 14, so I'm going to have a positive and a negative. And I have to wind up with them multiplying to give me that 14 and adding together to give me minus 13. So it's going to be plus 1 and minus 14. So now I've got my two values for y. Y can be minus 1 or 14. Now it would be easy at that stage to breathe a sigh of relief and think you've answered the question. But you haven't yet, I'm afraid, because it asks me to find the coordinates of A and the coordinates of B. And what we've done so far is find the y coordinates of both of those points. So each of those y coordinates has a corresponding x coordinate. And to find the corresponding x coordinate, I know already that x is 2 times y minus 1, twice y minus 1. So if y is equal to minus 1, which was the first of my solutions for y, then x will be twice minus 1 minus 1. So x will be minus 3. So that's one of my points, minus 3 minus 1. And then my second possibility for y was when y equals 14. So again, I'm going to find the corresponding value for x. So x is going to be twice 14 minus 1. Well, that is 27. So I've got my second solution, which is 27, 14. Now let's look back at the question and check we've answered it correctly. Find the coordinates of A and B, showing clear algebraic working. Yep, I think we've done that. Okay, I'm going to leave that there for a minute for you. Okay, hit like if you're happy with that. Ask me a question in the comments if you'd like to. Well, nobody's hit like yet, so I'll pause. Thank you, Pizza. If you can double check my work. Anyone's welcome to double check my work. I'm not immune to mistakes. Perhaps hit like, tell me you're happy with that solution as and when you are, and I'll pause for a minute or two. If you've done it and you're happy, then you could move on to the next question, which is about sequences. You can get ahead of me. Okay. Yeah, of course, you're extremely welcome to use this for fun. Or is it serious? I don't know. But you see, the thing is that if you want to lark around, there's a limit to how much impact you can have on the rest of us. So you can do what you like, really. But GCSE in school in Scotland, well, you will find every topic that we're doing today, even though it's from Edexcel IGCSE, is going to be on your paper. All these topics are the same for every exam board. Okay. Right. I'm thinking of moving on. I haven't got any. Nobody's really hit like, so I don't know whether to carry on or not. I've got 13 of you. Shall I carry on? Right. Nobody's shouting at me to wait. So I'm going to move on to question 2 now. Okay. Right. Yeah, I know there are only 5 on mine, but anyway, that's from the beginning of the thing. Oh, good. Okay, right. So we're ready. Okay, thanks, Pizza. Right, we're moving on to the sequences question now. Oh, look, right, here you go. Like, here's a quick mention of my past paper club. I've got 3 spaces left on my past paper club. So if you want to know about it, then send me an email and I'll send you some more details. Mr. Wright at mrwright@igcsemaths.com. Okay, send me an email if you're interested in doing my past paper club. Right, now let's move on to the next question. Right, here we go. Now, in an arithmetic series, okay, the first thing I'm told here is that the 6th term is 39. And then I'm told that the 19th term is 7.8. Work out the sum of the first 25 terms of the arithmetic series. Right. Well, the minute it says the 6th term is 39, I'm thinking, right, okay, T6 is equal to 39. Now, T6, that's equal to the first term, isn't it? A, plus how many differences? Let's have a think. So here's the first term. And I've got to get up to the 6th term, right? First, second, third, fourth, fifth, 6th. There's the first term. I need to get up to this one. How many D's am I going to add on? 1, 2, 3, 4, 5. So this 6th term is equal to A plus 5 differences. So that's an algebraic representation of the 6th term, and I know that the 6th term is 39. Now, in the same way, I can write an equation for the 19th term as well. The 19th term is the first term, A, plus 18D. And that's going to be 7.8. Okay, now I have two equations which I can solve simultaneously to find A, the first term, and to find D, the difference between the terms. And then when you've solved that simultaneously, you can use your formula for the sum of the first n terms in an arithmetic sequence, which I'll give you here since it's on the formula sheet anyway. You can use your formula to work out the sum of the first 25 terms. Okay, so that is your technique for this question. So I'll be quiet for a sec, but I think that you should be solving those two equations simultaneously and then using your values of A and D to find the sum of the first 25 terms. I'm looking at the comments in case anybody wants to ask anything. Okay, right, so I'm going to solve those two equations simultaneously now. Now, of course, you can do them in lots of different ways. Because they've already got 1a, each of them has already got 1a, I'm going to subtract one equation from the other. I'm going to call that equation 2 and that equation 1, and I'm going to do equation 2 subtract equation 1, because that's going to eliminate the a's. It's going to give me 13d is 7.8 minus 39. 7.8 minus 39 minus 31.2. So I can divide both sides by 13. Gives me D is minus 2.4. So now I'm going to use, I'll use the first equation. A plus 5D equals 39. So D is minus 2.4. So that means that it's going to be A plus minus 5 times 2.4, 12, equals 39. So A is going to be 51. Okay, now I know A and D. So I think I can now work out the sum of the first 25 terms. The sum of the first 25 terms is going to be 25 over 2 multiplied by twice A, 102, plus n minus 1, so that's 24 times minus 2.4. And so you can simply put that into your calculator. And when I do that, I get the answer 555. So that is my solution to that sequence question. And it relied on you knowing how to write equations for each of those two terms. Okay, I'm back looking at the comments. Nobody said anything, so perhaps you're happy with that. I've got 6 likes on the screen, so hit like if you're ready for me to move on, or some other reaction. Or tell me in the comments you're ready to move on, I don't mind. Or ask me a question. When are you usually live? So you're going to come to all the lessons. Well, I'm flattered. There's another lesson tomorrow. I think you can look at the YouTube channel and see when they are. You could join my mailing list and then you get a message as well. I'm doing grade 7 questions tomorrow at 11:30. Okay, so that's your next one. Okay, are we ready to move on? Nobody's talking to me, so I don't know whether to move on or not. Incidentally, the next question on proportion, if you're now looking at that, is, I think, one of the hardest questions that we're doing today. But I have this issue. Oh, hi, Archie, I'm glad you made it. Hi Solara, glad you've made it too. Right, I'm going to move on to proportion. Now, I really dislike these questions on proportion when there are three variables and two equations. Okay, so I will do my best to make it as clear as I can. To start with, I think I'll just be quiet while you have a look at the question and have a go at it. And if there was anyone here, Pizza, who's doing A-level, I'd hope you just whiz through this question. Okay, so no pressure. These proportion questions, I hope you're working on this one now, are quite straightforward, I think, when there's just two variables, but trickier when there are three. Incidentally, each of these questions is the hardest question I could find on each of these topics. So when you do your papers, I reckon you'll have about 2 questions at this level of difficulty. Okay, so if you find yourself thinking, crikey, this is hard, then that doesn't mean you're going to find all of your paper hard. Okay, I'm going to make a start on this. Now, it tells me first of all that y is inversely proportional to the square root of x. So I'm going to write y fish sign 1 over root x. And that means that y equals k over root x. Now, generally, in proportion questions, that's enough. And then you put in two values for x and y, and you find k, and then you use k. And that's generally as hard as the questions get. But unfortunately, in this case, we've also got to deal with the fact that x is directly proportional to t cubed. So I'm going to write x equals pt cubed. I just need to use another variable. I've used k, so I've just got to use something else. So I've chosen to use p. Now, we've got two equations now, one linking y to x and the other linking x to t cubed. And do you see the information here we're given is about y and t? So we need to combine our two equations. So we've got an equation that links y with t. So what I'm going to do is I'm going to take this expression for x here and substitute it into this equation here. So I now know that y equals, rather than writing k over root x, I'm going to write k over the square root of pt cubed. And now I have one equation that links to the other y and t. Okay? Right. Now this is where it gets slightly tricky. What you want to do is you want to manipulate this equation so that it looks a bit easier to deal with. What I mean is I want the y's and the t's separate. At the moment, the t is kind of embroiled in all of this, right? So I'm going to write this as y equals k over, and the denominator there, I'm going to write it as the square root of p times the square root of t cubed. And then I'm going to write this as k over root p times 1 over t cubed. So I've kind of separated out. So now I've got this, whatever I'm multiplying the t by, I've got it kind of separate. And now I'm in a position to use the information that they've told me. Now they've told me that y equals 8 when t is 25. So I'm going to substitute both of those values into my equation, and that's going to enable me to find the value of this constant here, the value of k over root p. And then I'll be able to use the value of k over root p to answer the question that they want me to answer. So 8 equals k over root p. I'll tell you what, I'll just call that c. Okay? Times 1 over the square root of 25 cubed. So that means that 8 equals c times, this is the sort of question you want to watch back again, okay? 1 over, now the square root of 25 cubed, if you put that in your calculator, is 125. So in fact, if I multiply both sides by 125, c is equal to 1,000. Now remember, c is this bit here. So now I can take this equation here and I can write y equals 1,000 times 1 over t cubed times 1 over the square root of t cubed. I can put 1,000 in instead of c. And now you can breathe a sigh of relief because now you're in a position to answer the question. The question is find the exact value of t when y equals 27. And here I've got an equation that links together y and t, and I've found that value 1,000, so I can use the equation now. Find the exact value of t when y equals 27. Okay, so 27 equals 1,000 times 1 over the square root of t cubed. Okay, multiply both sides by root t cubed. 27 times root t cubed equals 1,000. Divide both sides by 27. So the square root of t cubed equals 1,000 over 27. Right, square both sides, and you get t cubed equals 1,000 squared over 27 squared, and then cube root both sides. You'll be pleased you've got a calculator. So you cube root both sides, and I know I'm doing it quite quickly, but you can follow this through on a calculator later, and you get the answer. T is 100 over 9, and that is the value of t when y equals 27. And that is one of the hardest proportion questions that I've ever seen on an IGCSE paper. Okay. Yeah, you can rejoin on an iPad. I'm sure you can find the link. All right. So I'm going to leave that there for a second. But if you want to practice those questions, those proportion questions where there are 3 variables, start off by rewatching this film, okay, and follow it through again. And you'll find many proportion questions on the YouTube channel. Right, I'm going to move on. Oh, he's back. She's back. Freon, are you? Sorry to ask. Is it Freon? And I don't know if you're a he or a she. It's not very good of me. But anyway, I'm glad you're back. Right, so we are moving on now to the next question. Okay, and hello. Good. Right, sorry to ask. Right, am I pronouncing your name correctly? Are you Freon? Right, now, here we go. I am going on now to, oh, look, there's another mention of Past Paper Club. Only three places left. If you're interested in joining Past Paper Club, we do a paper every week on Zoom, and you can send me an email and then I'll send you details. Right, okay, there you go. That's enough of that. Right, so we've got a coordinate geometry question now. Here it is. Okay. We've got a curve with this equation and a straight line with this equation. And we're told that the curve and the straight line intersect at 2 points A and B. And we're asked to work out the exact length of A and B. And then in typical grade 9 question style, they then tell us what form they want the answer in. So let's worry about that last bit later on. Okay, for now, we've got 2 equations. X squared minus x plus y squared equals 10. And x minus y equals minus 4. And we have to find the length, the distance between the points where they intersect. Well, let's first of all find the coordinates of the points where these 2 curves intersect. Okay, now to do that, let's get an expression for y from the second equation and then substitute that into the top equation. The second equation tells me that y is equal to x plus 4. So I'll be quiet for a minute or two, take that expression for y and substitute it into the top equation, and then see if you can solve the resulting equation and find what x is. Okay, just don't mess up your algebra. Right, I'm looking at the comments in case anybody has anything to say. Okay, nothing new there. We've only got 7 people now, so our numbers have gone down. So I hope that you're solving those 2 equations there simultaneously. Right, I'll make a start solving this one now, so you can compare my solution to yours. So I've done all my multiplying out and simplifying. So I'm left with a quadratic equation which I've set equal to 0. And now I'm going to factorise that. Now you don't have to solve this by factorising. You can solve it by using the formula if you want to. So I've factorised it and I've got 2 solutions, 2 values for x. And all I've got to do now is find the corresponding y value for each of those values of x. Well, Freon, I'll do my best, but you might have to, write something in a diary. Okay. Right, so I've got my values of x there, and now for each value of x, I'm going to find the corresponding value of y, because I know that y equals x plus 4. So if x is minus 3 over 2, then y will be 2.5, won't it? Just x plus 4. And if x is minus 2, then y will be just 2. So the 2 points where they cross are going to be minus 3 over 2, 2.5, and minus 2, 2. So those are the 2 points where my curves cross. So now let's go back to the question. It wants me to work out the exact length of A and B. So I've got to work out the distance between these 2 points here. Well, if in doubt, sketch it out. I'm going to draw a sketch and plot those 2 points. Okay. Now, because I'm dealing with halves and stuff, I'm going to just I'm going to have 1, 2. I'm doing 2 squares to a unit, look. Okay. Because then I can easily plot minus 1.5, 2.5 is here. And minus 2, 2. Minus 2, 2. Oh, it's there, look. So those are my 2 points. And I'm being asked to find the distance between them, the length of AB. So I'm being asked to find the length of that red line there. Okay, being asked to find the length of this red line, the distance between the 2 points. So how do I find the distance between those 2 points? Well, with luck, you'll remember that you can use Pythagoras to find the distance between 2 points on a coordinate grid. That's my right angle triangle there. Now, can I work out what the length and the width of this triangle are? Well, in fact, that's a half, and that's a half. So I can find the length of AB by using Pythagoras. It's going to be the square root of 1/2 squared plus 1/2 squared. I'm finding the length of the hypotenuse of that triangle. So a half times a half is a quarter. So what you've got here is you've got the square root of a quarter plus a quarter. So you've got the square root of a half. So now I'm thinking I've answered the question. I found the distance between A and B. It's the square root of a half. Okay. I haven't quite finished the question. Okay. My x values are the same number but positive. Well, do you notice how I've got +3 and +2 in my bracket? So that gives me negative values for x. Okay. I wonder if you've put everything on the right-hand side and actually, have you got this equation here? Or have you got minus 2x squared minus 7x minus 6 equals 0? I'm not sure. Okay, so I'm going to carry on though. I've got a distance between A and B of the square root of a half, but it asks me to give it my answer in the form root A over 2, where A is an integer. And so far, my answer is the square root of a half. Well, that's not in the form root A over 2. So I'm going to need to manipulate my answer until it looks like square root of something over 2. So this is what you have to do. You have to think about the square root of a half. You have to think, oh, well, that's the square root of 1 over the square root of 2. But look, my answer, it has to have 2 on the denominator. So what am I going to do here to change this root 2 into a 2? Well, the answer is it wants you to multiply that by root 2. It wants you to rationalize that. So you have to do the same to the top as well. So you get root 2, root 1 is just 1, isn't it? So that's just 1 times root 2 over 2. And now my answer is in the form square root of something over 2, isn't it? It's the square root of 2 over 2. And that is the answer that you need to get full marks on this grade 9 question. If you don't do that last bit of manipulation, you'll only lose 1 mark. But of course, if you want to go for that 9, you want to try and get every mark you can out of every question. So that is what you have to do to get full marks on that question. Okay. Right. Okay, so I'm hoping that you're happy with that question. Hit like a couple of times. I've got 7 likes so far on my screen. So if you can hit like or tell me in the comments you're ready to move on when you're ready to move on. But I'm only going to give you 30 seconds or so because we've got to crack on. Otherwise, we'll be here all day. Okay. Oh, we've only got 7 people now. Okay, never mind. Right, incidentally, tomorrow, the grade 7 Zoom is well worth coming to. It's easier questions, of course, but you need to get all of those questions correct as well if you want to get your top grade. Right, I'm moving on. Okay, oh look, another mention of Past Paper Club. Have you sent me an email yet? That's my email address, mrwright@mrwright@igcsemaths.com. If you want to know about Past Paper Club, send me a message, even though I'm getting bored of that now. Right, here is the next question. I'll leave it on the screen for you to have a look at. It's one of those wordy questions, so with luck you've got it printed out and you can underline the important stuff as you read it. Good, I'm pleased you're coming tomorrow. You just have to put it in your diary. Okay. All right, here we go. Right, the diagram shows a solid made from a cylinder and hemisphere. The cylinder and hemisphere are both made from the same metal. Okay. The plane face of the hemisphere coincides with the upper plane face of the cylinder. Well, all that's saying is that they fit together. Okay, that's all that means. The radius of the cylinder and the radius of the hemisphere are both x. Well, that's marked on the diagram, so I tend to tick it off if it's marked on the diagram. The height of the cylinder is 3x. That's marked on the diagram. The total surface area of the solid is 81 pi square centimeters. Oh, that's going to allow us to find out x, isn't it? Because if I work out the total surface area of this in terms of x, then I can write that equals 81 pi. Okay? So we'll bear that in mind. Right, let's read on, I suppose. The mass of the solid is 840 grams. The following table gives the density of each of 4 metals. The metal used to make the solid is one of the metals. Determine the metal used to make the solid. All we've got to do is find the density of this solid, and then we can see whether or not it's aluminium, nickel, gold, or silver, depending on what the density of the solid is, right? So we have to find the density of the solid. Okay, to find the density of the solid, well, it's mass divided by volume, isn't it? So I really need to know the mass of the solid. I know the mass of the solid. It's 840. So now all I need to know is the volume of the solid. How am I going to find the volume of that solid? Well, I need to know the value of x, don't I? How am I going to find the value of x? Well, I'm going to use the fact that the surface area is 81 pi. So we're going to use the fact that the surface area equals 81 pi. And we're going to write an expression for the surface area of this solid. Okay, so that's what I'm going to do now. An expression for the surface area of the solid equals 81 pi. Right, the surface area of the solid. Well, first thing it's got is a base, isn't it? And I know the area of that because it's a circle. So the area of that is pi r squared, and r is x. So that's just pi times x squared. And that's the area of the red face there. Good. Next, I'm going to do this face here, the curved face. It's like the label on a can of baked beans, right? I've got to find the area of that face. Now, that is the curved surface area of a cylinder. And I have a feeling that the formula is given to you on the formula sheet. But it is going to be the height of the cylinder, the 3x, times that length. And that length is the circumference of the circle. So it's going to be 3x times the circumference of the circle, which is pi times the diameter, pi times 2x. So far I have got the area of the bottom and the curved surface area of the cylinder. And so the only surface that I need to add on now is the surface area of that hemisphere. Well, the surface area of a sphere is given to you on the formula sheet. It's 4 pi r squared, and we've got half of it because we've only got a hemisphere. So there is an expression for the surface area of the whole solid, the area of the bottom, the area of the side, and the area of the dome on the top. And I know that that equals 81 pi. So here is an equation which I can solve to find x, to find the radius of the cylinder. So with any luck, you're a step ahead of me, and you're solving that equation to find x. Okay, I'm not sure what you mean by a fact family, so you can tell me about that when you've got a moment in the comments. Right, I'm going to carry on and solve this equation. Now, the first thing I'm going to do is I'm going to just look at this left-hand side. Pi r squared plus, 6 pi x squared plus 4 pi x squared divided by 2 is 2 pi x squared, and that was okay, equals 81 pi. Now do you see how everything has a pi in it? So I'm going to divide everything by pi. x squared plus 6x squared plus 2x squared equals 81. Hey, hey! 9x squared equals 81. X squared equals 9. X equals 3. Look at that. I know the radius of the cylinder. I know that the radius of the cylinder is 3. Okay. Nobody. Oh, he's going. Freon's gone. Okay, right. So now I am going to use that value of x now, okay, to find the volume of the cylinder, the volume of the solid, because then I can find the density of the solid, and then I can ascertain which of these metals it is. So the volume of the solid, right, V equals, well, it's going to be the volume of the cylinder, which is pi r squared, the area of the top, pi times 9, times the height. Well, the height is 3x, and x is 3, so that's 9. That's the volume of the cylinder, plus the volume of the hemisphere. Now, the volume of a hemisphere, the volume of a sphere is 4/3 pi times r cubed, and I've only got half of it, haven't I? So I'm going to divide that by 2. So that tells me that the volume of my whole shape, if I put all that in a calculator, is 99 pi. So that tells me that the density of my shape is the mass, 840, divided by 99 pi. Stick that in your calculator and you get 2.7. So my solid has a density of 2.7. Look at the table and you can see that the solid is therefore made out of aluminium. Okay. And that is the solution to that question there. Right. Okay. Now I'm feeling as if we have to move on, because we need to keep on moving forward, and you can always rewatch, of course. Okay. Right, we've only got 6 people left. I'll tell you what, let's choose a couple more questions and do them, and then call it quits. And I can always put the solutions to the other ones on the YouTube channel. So we have got several to choose from here. We've got a similarity question. We've got a question involving surds and intersecting chord theorem. Let's do that one because that's a tricky question. And this is a question, intersecting chord theorem is a circle theorem which occurs only on Edexcel IGCSE, so they like to put it in. Okay, so we're going to do this question here. Now, just to help you with that, let me remind you of the intersecting chord theorem. Okay, so in this case, here's a circle, right? And we've got 2 chords which intersect. Now, I find it much easier to label as follows, okay? I always label one of the chords AB and the other chord CD, and I label the point where they intersect P. And then I can write down the formula really easily, because I just write A, B equals C, D, write them in alphabetical order, write in your P, put in your times signs, and that tells me the formula for the intersecting chord theorem without me having to think. So when we apply this to this question here, we've already got one chord called AB. I'm going to call this point call it P, rename it P, and then this chord here is going to be called ABCD. And now I'm ready to write down the formula in the way I like to do it. Okay, alphabetical order, ABCD, put in your P's, put in your multiplication sign. Right, I'll be quiet for a minute. You have a look at that question there. Okay. Right. Now in this question, you're asked to find the length of AB. So I'm going to call the length of AB x. Now I'm going to use my formula here. AP times BP equals CP times DP. So I'm going to have AP. Well, that's the whole length, isn't it? So that is x plus 2 plus root 5 times by BP. Well, that is 2 plus root 5 equals C to P. Well, that is this plus this. So CP is 4 plus 3 root 5. And that's being multiplied by dp, which is 2 root 5. Okay, so here's my expression, which I'm going to need to simplify to find x. Right. Let's write this one the other way around. So we're going to have 2 plus root 5 multiplied by x plus 2 plus root 5 equals, and this is 2 root 5 multiplied by 4 plus 3 root 5. Now I've just got to multiply out these two brackets on the left and multiply out the bracket on the right. Now when I multiply out this bracket on the left, it's going to be 2 multiplied by that bracket, and then it's going to be root 5 multiplied by each term in that bracket. So let's do twice the bracket first. 2 times x is 2x, 2 times 2 is 4, 2 times root 5 is 2 root 5. And now let's do root 5 times each of those brackets. So I'm going to have root 5 times x, root 5 times 2, and root 5 times root 5 is just 5, isn't it? Equals, let's multiply out this bracket on the right-hand side. 2 root 5 times 4, well, that's 8 root 5. Now, 2 root 5 times 3 root 5. Well, that's 2 times 3 times root 5 times root 5. Well, that's 6 times 5. So it's just 30, isn't it? There we go. All right. Now, simplify what I've got on the left. I've got 2x and root 5x. And then I've got the 4 and the 5 gives me 9. And then I've got 4 root 5. And that equals 8 root 5 plus 30. Now I'm wanting to find the value of x here. So I'm going to need to put everything with an x in it on one side and all the other rubbish on the other side. So I'm going to have 2x plus root 5x here, and then I'm going to minus 9 from both sides, and also minus 4 root 5 from both sides. So I'm going to have not 8 root 5 anymore, but only 4 root 5, and then plus not 30, but 21. Now I need to make x the subject of this, so I'm going to factorize the left-hand side and then divide. So x lots of 2 plus root 5 equals 4 root 5 plus 21. So now I can divide by that bracket. 4 root 5 plus 21 over 2 plus root 5. And have I finished? Well, you haven't finished, because there's another of these grade 9 things. Look at this. Show that the length is p root 5 plus q. So I need to write this as p root 5 plus q, something times root 5 plus q. It doesn't want it as a fraction like that. So what it's asking me to do now is to rationalize the denominator. So I've got x is 4 root 5 plus 21, but it's asking me not to write it as that, but instead I need to rationalize the denominator. So I'm going to multiply top and bottom by 2 minus root 5. Okay, it's like a final sting in the tail on these grade 9 questions. So I'm going to get, I've got to expand these brackets on the top, haven't I? Okay, so it's going to be 4 root 5 times 2, well that's 8 root 5. 4 root 5 times minus root 5 is minus 20. 21 times 2 is 42. 21 times minus root 5 is minus 21 root 5. And all of that is over. Now I'm going to expand these brackets. Well, of course, the denominator, you get rid of those root 5 terms, don't you? So you end up with 2 times 2 is 4, minus root 5 times root 5 is 5. So you end up with, simplify the top, minus 13 root 5 plus 22 over minus 1, which is just 13 root 5 minus 22. And now I've written it in the form something root 5 plus something, which is what it wanted. And that is the answer to that grade 9 question. There is so much in that question for you to get your head around. So it's well worth rewatching this part of the film if you want to practice that really very tricky question. Okay. Right, we have been going for an hour. I'm going to call it quits. Okay, if you would like me to tackle any of the remaining questions, then send me an email and I will put a film out of the remaining of any questions you want me to tackle over the next couple of days. Okay, in the meantime, if you want to join me for Past Paper Club, please do. Just send me an email, mrwright@igcsemaths.com. I'll put my email address in here, mrwright@igcsemaths.com. Send me an email and I'll send you details of Past Paper Club. I've got a nice little film for your parents to watch if they want to know what it's all about. If you are aiming for grade 7, 8, 9, which I guess most of you are, then come to the live tomorrow at 11:30 and I will have sorted out the tech issues by then, so we'll be able to make a prompt start. And you can download the questions from that from the description in the film about the live. Okay, that's it. Thank you very much for coming, and I will see you, I hope, tomorrow at 11:30. Okay, goodbye, farewell.